All right, this is section 7.2 of confidence intervals and sample size, and we're going to be working with t values this time instead of z values, so you're going to use a different table. So this one, again, I've got some issues here with notation, so we need to sort of get rid of some of this and try to, this should be a sigma right here. I'm going to just mark that out. Looks kind of messy, I know. I had typed over it at one time, but so this is this should be a sigma, and this should be a sigma, okay? So confidence intervals for the mean when sigma is known. We did that one. This one is confidence intervals for the mean when sigma is not known, and it also has to do with a small sample size. So we're not going to do 7.3 and 7.4 in this particular unit. Objectives: find a confidence interval for a variance and standard deviation. That's the sixth one, and somehow I may have left the rest of the objectives off, but anyway. All right, 7.2, again, we're looking for the confidence interval when your sigma, so mark that out, and again, mark this out. Not real professional, but it'll work. Okay, when sigma is unknown, so when sigma is not known, and it has to be estimated by using S, which is the sample standard deviation, and then when S is used, the sample size is less than 30, critical values greater than the values for Z, alpha over 2. Remember we talked about that in unit 7.1. In order to keep the interval at a given level, such as 95%, we have to change the way we do this. And so those values are taken from the student t distribution, most often called the t distribution. It was called student t because when it was first developed, it was developed by a student of a more famous fellow, and so it was called the student t. That has no real meaning other than that's the way it was named. Characteristics for the t distribution. The t distribution is similar to the standard distribution in that it's bell-shaped. It is symmetric about the mean, just like the normal distribution. Mean, median, and mode are equal to 0 and are located at the center. So if we're drawing a t distribution, we're still talking about, a bell-shaped distribution. Your mean here is at 0 in the middle, and it's equal and even on exactly the same on either side, even though my drawing is not perfect. Curve never touches the x-axis out here on the ends, just like the z distribution. So those are the ways that it's similar to to the standard normal distribution that we would use z tables for. Characteristics of the t distribution: it's different in the variance is greater than 1. It's actually a family of curves based on a concept called degrees of freedom, and that's degrees of freedom is related to the sample size, and so we're going to have to know this degrees of freedom for our so this is going to be an important number that we're going to have to know, and we'll have to calculate that for individual problems. And again, it's related to sample size. It's not difficult, but that's on the table when we look this up. As the sample size increases, the t distribution gets closer and closer to the standard normal distribution. So the smaller the sample size, the more it's not exactly like the standard normal distribution. So let's go on. DF is used for degrees of freedom. And this is the formula that you'll need, and it's, again, really nice. It's not bad, so don't get, there it is. Isn't that difficult? Oops, I marked it out. DF is equal to n minus 1. So let me, whoops, I didn't know how to do that either. Okay, degrees of freedom is n minus 1. I just got rid of the slide completely. That was not what I wanted to do. Okay, for a specific confidence interval, when the sigma is unknown, so again, this is not what we want that to be sigma, and n is less than 30. Again, that's your sample size. We're going to use our, instead of sigma, we're going to use S, which is the sample standard deviation, excuse me. We're going to use a t-score, t alpha over 2, instead of the z-score. So remember, you have to pay attention to sample size to decide on a test whether you need to use a z or a t. And degrees of freedom, this was what was really important from the other slide, is n minus 1. All right, so here's an example. Chapter 7, confidence intervals and sample size. This is example 7.5 on page 371. Now here's our table. Table F this time. It's a t distribution. Okay, so we're looking right here at our t distribution. And confidence intervals of 50. See if I can find a highlighter that will be enough difference, but that, okay, we've got our confidence intervals here, 50, 80, 90, 95, 98, 99%. Those will be stated in the problem, so you'll know which column to use. And here's our degrees of freedom down on the side. So here's our confidence intervals, and then our degrees of freedom will be down the side here this way. And again, that's the sample size minus 1. So what we're looking up here in this page is we had a sample size of 22 because the degrees of freedom are 21, and we want a 95% confidence interval. And we read from the left over here, there's your degrees of freedom. And then we look at our sample size, our confidence interval, and read down till we find the t of alpha over 2. Okay, so this is reasonably, in some ways I think it's maybe easier than the z table, but you still have to go to a table and get your information, and they will be included on your test when you take a test over this. All right, this is 7.2. This is a problem, page 372. Sleeping time. 10 randomly selected people were asked how long they slept at night. The mean time was 7.1 hours, and the standard deviation was 0.78. Find the 95% confidence interval of the mean. Assume the variable is normally distributed. So, sigma is unknown right here. So we're going to, right here, our sigma is unknown. That's important that, we remember that it can be stated, but often you can tell just by the wording of the problem whether your sigma is an unknown or not. And we're going to list our information. The mean, which is our x bar. Okay, so x bar in this problem, okay, is 7.1 hours. So I like to list everything. Our standard deviation for the sample was 0.78 hours. Our sample size, n, okay, was 10. And we want a 95% confidence interval. We need to know that for the table. Okay, and our degrees of freedom is 9, 10 minus 1. So these are the last two things I wrote are what we're going to need to know for our table. So what we really need to know for our table are these two values right here, the confidence interval and the degrees of freedom. So we look with 9 degrees of freedom, go to table F, 95% confidence, and you should run into the t-score of 2.262. Make sure that you're looking that up right now so you can see that you get it. Now we've got our formula, x bar minus t alpha over 2, sample size standard deviation over the square root of the sample size. Now again, be sure you use here, you're using n. This is not right here. That's not degrees of freedom, that's the sample size. So be sure that you're using that, not using something that you shouldn't. So remember that you're using n right there, not degrees of freedom. So we have we're looking for a range again. We're looking for a range, just like we were in 7.1, where within that range we can be 95% confident that our mean of the population will fall in that range. So we do the x bar minus to the left because that's less than, and then over here, maybe we'll highlight that just because that, okay, this one's a minus and this one's a plus, and so we've got less than the mean on the left, the population mean, mu, in the middle, and greater than. So we've got the population mean falling between a low value and a high value for our answer. So down here, we've put the things in. Our formula, we've just listed them. You can see our S is 0.78. Square root of 10 is square root of n. We looked up our t-score, and our x bar was 7.1. So we subtract that combination from the mean, from the x bar, and add it on the other side. Our final answer then will be this range from 6.5 to 7.7. We can be 95% confident, and you need to make a statement kind of like this. You will be 95% confident that the population mean is between 6.5 and 7.7 hours. Okay. So let's look at another example. This one's on page 372. It's about home fires by candles, for people that burn candles. This time you've got data, so you're going to have to do your 1-bar stats and find the mean and standard deviation. If you want to crank it out by hand, that's fine. Or again, you can put it in the list, which I would recommend. We want a 99% confidence interval this time. So if we list our data, we've got, whoops, I don't want that. I want my pen back. Okay, we want a confidence interval. I'll just put confidence is 99%. Okay. And what's our sample size? Well, we need to count. Here we've got a sample size of 1, 2, 3, 4, 5, 6, 7. Okay, we've only got 7 samples. So n is 7. So our degrees of freedom, which we need to look up on our table, is going to be 6. We need to find our x bar, and we need to find our s. Okay, we're going to find those using our calculator. Go in and do your 1-bar stats on this set of data. So hopefully you know how to do that, and you do it, and we find that your x bar is 7041.4 and s is 1610.3. Reading from the table, finding our degrees of freedom in 6 and 99% confidence, we find our t-score is 3.707. Now we just put that in the formula. You're going to have to memorize the formula. Now I will say, on your final exam, if I haven't already told you, you will have your first section is going to be a matching section with every one of the formulas in these last 3 chapters there. But you're going to have to be able to recognize them. They're not going to be wrong, but you have to know which one is which. get those labeled, and then you're good to go for the, you don't have to come up with a formula out of your brain, but you have to know which is which. Okay, so we go on. We put everything, all our data into the formula that we just found. 7041.4 minus the t-score times s over the square root of the sample size. Again, don't forget, you use the sample size on the bottom, not the degrees of freedom for this bottom number. You get a range, and the range, this is your answer here. Below and above the mean. If you get two numbers above the mean, you've done something wrong. Or two numbers below the mean, you've done something wrong. So be sure you've got a number below the mean and a number above the mean. 4,785.2 is less than mu, and mu is less than 9,297.6. So the population mean, we can be 99% confident that the population mean of the number of home fires started by candles each year is between 4,785.2 and 9,297.6 based on a sample of home fires occurring over a period of 7 years. Make that final statement as best you can. Okay, I believe that's the end, but let me go another slide just to be sure. Okay, yes it is. All right, so I hope you have can work on the homework and get this done for 7-2. I will have Chapter 8 and 8.1 and 8.2 up soon on videos. Be sure to contact me or post on the discussion board if you're having any kind of problems.